All right, so we're going to look at exponential decay. Okay. And you remember from exponential growth, we had this formula. Y was equal to the initial amount times 1 plus the rate raised to the power of time. Now, this specifically is for growth. What makes the equation for decay similar yet different is instead of adding the rate each time, we're going to be subtracting the rate each time. So the decay is just a little different. There's a minus sign here as opposed to a plus sign. So this is what makes it decay, and this plus is what makes it growth. Okay, so let's start with this example. If we have a philanthropist that has an account with $471,000, and at the end of each year, okay, he's not going to add anything to this amount. At the end of each year, he's going to donate 14% of this to a charity until all the money runs out. So he's saved up all this money. He wants to give it away. Every year, he's going to donate 14% to a different charity until there's nothing left. Now, what makes this difficult that we can't just calculate straightforward is once the first year's over and he donates 14% of this, okay, that'll be about $65,000. Then, starting in year two, he does not have 471 anymore. He has around $405,000. And so 14% of that number will be a little bit lower. So we're going to use our exponential um, subtraction problem. Okay, I'm sorry, exponential decay, which uses subtraction. So, and we want to know after 6 years, essentially, what is the total amount? So, what is it in 6 years that he has left in the account? So rather than each time we saw the proof yesterday or kind of an example, we add the rate each time we have an amount, we're going to add 14%. We have a new amount, we're going to add 14%. This is different. We have an amount, we're going to subtract 14%. And we have a new amount, we're going to subtract another 14%, 6 times over the course of 6 years. So here, then my total amount left is equal to my initial amount. So in this case, that's 471,000 times 1 minus my rate, which is 0.14. And we're going to do this for 6 years. Okay. All right. So 1 minus 0.14, that's kind of the first step here. That's going to give us 0.86 raised to the sixth power. And this will be the same, 471,000. Okay. So now 0.86, we can go ahead and raise that to the sixth power. So 0.86, and we're going to raise to the power of 6. All right. That's going to give us 0.404567. Okay. And of course, oops, I forgot to change colors here. That's okay. 471,000. All right. So now I simply plug this into my calculator. 471,000. And I multiply that times 0.404567. And I'm left with, I know this is money, so I'll do my money sign, $190,551.06. Okay. Interesting. The answer had the same thing, but they had 17 cents. So they rounded a little bit different. Um, let's see if we have, it's kind of a glare there, isn't there? Okay, so 0.86 raised to the sixth power. I won't do any rounding, and I'll multiply that straight up by 471. So that's where they're getting it. Okay, they had a little bit more accurate of a number. Since I rounded here, I did not put the rest of the digits here. If in the calculator, when you put the 0.86, sorry, 0.86, when you raise to that sixth power, notice how many decibels it gives me. So if I keep all of those and immediately multiply by 471,000, that's where I'm getting the same as my answer sheet. So 190, 551, and 17 cents. Because you see here the 1, 6, and then the 7. Okay, good. So here, and we can kind of double check this idea, and I want to do this just to kind of show you. If we kind of do this kind of roughly straightforward, so 471,000, and I'm going to multiply that by 14%. So that's 65,000. Okay. Whoops, 65,940. So 471,000 minus 65,940. So I'm left with $405,060. Then I multiply that by 14%. I have 56,708.40. Let me go ahead and make that negative, and I will add that to 400. I think it was 405,000. Oh, I didn't write that down, so I'm probably not going to be able to do that right. Anyway, you could see that decreasing, and we could work it out. Since I did the addition one last time, we don't necessarily need to step through this to that level. But you could see on the decay, the biggest thing to learn here is that I'm subtracting the rate rather than adding it. Because each iteration, I'm taking away money. I am not adding money. All right, so let's look at another example. Okay, so an architect is designing a tapered office tower, okay, to where the ground floor, which would be 0, okay, is the largest, and the floor space is reduced by 12% per floor. So if we look at this, here's floor 0, okay. Then the next floor is going to be reduced by 12%. Then we're going to be reduced by 12%, so on and so forth. Okay, so it's going to have this tapered look to the office building, almost like it's coming to a point in a pyramid, right? And so each floor is reduced by 12%. Okay. All right. If the ground floor, if its area, okay, so ground 0, the area here is 14,500 square feet. I want to know what is the area of the 10th floor? What is the area of the 10th floor? Okay, so let's go ahead and plug using our decay formula. We have our initial value, 1 minus the rate raised to the number of iterations. So here, my initial value is the ground floor, which is 14,500 feet squared, times 1 minus the 12% drop, which is 0.12, raised to, and we do this once every floor for 10 floors. Okay, we're going to be doing it 10 times. So there, it's going to subtract 12% from this, get that total, subtract the next 12%, get that total, subtract the next 12%, all the way up to floor 10, right? So here would be floor 1, 2, 3, 4, so on and so forth until we get to 10. All right, so let's go ahead and do our math here. This would simplify down to 0.88 raised to the 10th power. This is 14,500. Okay. And I'm going to do the same thing I did before here to get the accurate number. So I'm going to take 0.88 and I'm immediately going and raise it to the 10th power. Okay, 0.88 to the 10th power. Okay, so that gives me that number. I'm going to take that number, multiply it immediately by this number, the 14,500. And that is going to give me 4,038. Okay. And we could do, whoops, 26 feet square. Let's see what they rounded to in the final answer. They want us to round to a 10th. Okay, so that would be right here, the 2, and then the next number is 6, so I'm going to round that up to a 3. 4,038 square feet. That is my answer here. All right. Let's do another example of the decay here, because I think examples are really helpful. So we're going to do one where somebody drops a bouncy ball, okay? And the bouncy ball is going to come down, all right? And the first bounce, um, it comes up, so it's dropped from this height here. This height here is 102 inches. So not quite 11 feet. Um, or not quite, I'm sorry, what is that? 10 feet would be 120 inches. 9 feet, 7 feet would be 70, so somewhere around 9 feet. All right, and then every time it bounces up, it's going to lose a little bit, right? And we've all seen this. We've dropped a ball, and we know that every time it bounces, it decreases a little bit. Well, this is going to decrease, all right, 15% of the height from which it was dropped. So here it's not thrown, it just rolls off. Sorry to get that right. It rolls off. So it starts exactly at 102, bounces, it's 15% less, which means then bounces and it comes up another 15% less. Then it comes down and bounces um sorry, another 15% less. So each bounce diminishes by 15%. So we're going to use our equation here, right? In this case, y is going to be our height. our initial height, and then 1 minus the rate at which it decreases, and then x is the amount of times um, that happens. Okay, so they want to know what is the height on the fifth bounce. So here's 1, 2, 3, 4. Let's draw this out. All right, so here is the fifth bounce. And then here, another 15% decay, another 15% decay. So essentially, what is this height after the fifth bounce? Okay, so after the first bounce, we're up 50%. Zero bounce, we're at 102. All right, so we'll go ahead and plug everything in. Our initial height from which it's dropped is 102. And then we lose 0.15 of the height, and we want to know what happens that after 5 times. So you can see how this is a lot easier to work with than calculating it each time. All right, so 1 minus 0.15, that's going to give us 0.85. We want that to the fifth power. Okay, so let's go ahead and here I'll just put it into my calculator. 0.85 raised to the fifth power. Okay, it's going to give me this long number here, 0.4437053125. And I'm going to multiply that by my initial height, 102. And that is going to be 45. We'll round to the nearest tenth, 45.3 inches. Let me double check my, oh, they rounded it to the 10th. So 257, or they rounded it to the hundredth. Sorry. So 257, the hundredth is 5, next to it is 7, so 0.26. All right, so 45.26 inches. There you go.